All right, guys, let's go to this Titan example. Now, before I get into this, has any of you ever wondered how we know the mass of celestial bodies?
Because we cheat with math.
Take a guess.
We just take a guess. Okay? Have any of you ever wondered?
Because people got in space with a really, really big scale.
We send a big scale over and put the mass of the celestial body on that scale, right?
Yes.
Yeah.
Where do we store this huge scale?
In
Outer
South
space, just
America.
hangs out there, right? And we probably built it from mass from Earth, right? So now the Earth lost a bunch of mass, and we're now getting further from the sun, which is why it's so cold right now, right?
Yeah.
Okay, no. There is no big celestial scale. There's not a big scale I can just throw these things on, right?
Are you sure?
Yes, I'm sure. Yeah. I think we would have seen it by now if there was.
Not true.
Okay. Now, there's no big scale. So, equation 7, V equals the square root of GM over R. I don't like this marker. Okay. This equation, you can kind of think of this as the celestial scale. Because what's something I can solve for in that equation? What's something I can solve for in the equation V equals the square root of GM over R? We can solve for mass, right? If we can figure out velocity, we can measure radius, right? We can solve for mass. It's our celestial scale. It figures out the mass of big objects. Right? So, some information about Titan. The first one is it has a period of 16 Earth days, and it has a radius of 1.22 times 10 to the 9th meters, right?
How do we figure out the so far?
What? Like the Hubble Space Telescope.
When do I look for Saturn?
When do you look for Saturn? Actually, if you go on to Google and type in which planets can I see right now, then it usually gives you a list of which ones you can see now and tonight and in the coming days.
Sure.
The planets are usually really bright, colorful stars. They look like stars, but they're not
They all
stars.
look like.
But they look like stars. And they'll be in one spot, like at 7, and if you look again at like 10, it's close to that, but it's moved much more than anything else around it. So that's how you identify it. Okay? Mars is usually red. Saturn is like bluish color. Looks blue when you see it. And they look like they're twinkling all the time because they're reflecting the light from the sun. All right.
Can you show us a picture?
Yeah, you guys can look it up on Google. Okay. All right. So to find the orbital period, we do 16, right? Times 24/1 times 3600 divided by 1. So we turn our days into seconds. How many seconds is that? How many seconds is that? 1,382,400. Okay? Or 1.3824 times 10 to the 1, 2, 3, 4, 5, 6 seconds, right? I think it makes it less complicated, right? So this is our orbital period, right? Right? And this is our radius. So what can we find using those two things?
The mass of something.
The velocity. So 2 pi r over t, v equals 2 pi times 1.22 times 10 to the 9th over 1.3824 times 10 to the 6th. What do we get? What's our orbital velocity for Titan? 5545. 5545 meters per second. Good. Okay. So that is the orbital velocity of Titan. Does that make sense, guys? Okay. Now, using this equation, V equals the square root of GM over R, we can figure out the mass of what? Titan or Saturn? The mass of Titan or Saturn? Saturn. Because Titan orbits Saturn. So a little schematic. I don't know what Saturn's continents look like. I don't even think it has continents. So here's Saturn, here's Titan. It's a gas giant, so it's composed mostly of gas. Okay. There's a hard or dense core in there somewhere, but it's mostly gas. Everything past the meteor belt. well, when you got to the core, the surface of Saturn, the dense core, there'd be so much pressure from the gas that it'd crush you. Okay. All right. So Titan is going around at 545 meters per second, going pretty fast, right? So this equation finds big M, which is the mass of Saturn. Good. Want to make sure I was pretty redundant about that. 5545 equals the square root of 6.67 times 10 to the negative 11. Big M over, where's my radius? 1.22 times 10 to the 9th. Right? Does that make sense? What do we solve this for now? M, right? We solve for M. First step is square rooting, or squaring. Then dividing by those two combined. And what do we get for a mass of Saturn?
I got 7,161,189.
7,116,1189 times 10 to anything?
No.
No, that's wrong. Anybody? Did anybody check their work in the book? Page 173?
No, because that's cheating.
It's not cheating, it's checking your answer.
Oh, I didn't think about that.
You previously.
Alright, I guess we'll have to go through it then. So, first step is to square. 5545 squared equals 6.67 times 10 to the negative 11th over 1.22 times 10 to the 9th times M, right? Why is it square it? Because we need to get rid of the square root. We got to do algebra. Right? So 6.67 second e to the negative 11 divided by 1.22 e to the 9. 5545 squared. Lots of fun numbers. So I got 307,47025 equals 467 times 10 to the negative 20th M. So now what do I do? Divide by the 5.467 number, right? Okay, and what do we get? We got 5.62 times 10 to the 26 kilograms.
That's a big number.
Okay, very big number, right? Saturn is one of the largest planets in our solar system. The big one bigger than Jupiter.
No.
Right? Saturn bigger?
Is Jupiter made out of water?
Yes, Jupiter's big.
Jupiter is bigger. They're both gas giants.
Yeah, Jupiter's big.
Okay, Jupiter's 50% bigger.
I was
All right.
gonna say the sun, but you
Now, if you look in your book, it says 5.69 times 10 to the 26th. Okay. Now, the big difference here is we're assuming a circular orbit. Is the orbit really circular? No. So this way was how we got close to the actual masses, but then later on, by doing some more difficult mathematics with elliptical orbits, they were able to exactly calculate the mass of the planets. Okay. So does that make sense? Okay. Now the second question, I know we got a little bit of time, so we'll get the second one set up. The second question said, what is the mass of the sun given the Earth, right? Right, guys?
Right.
What's the orbital period for the Earth?
365
365.25 days. That's why leap year happens every 4 years. Okay? So that way we can stay on track. Right? How far is the Earth from the sun? How far is the Earth from the sun?
1.5 times 10 to the 11.
Good. Radius equals 1.5 times 10 to the 11th meter. Sergio, stop talking. Okay, what's the question?
What leap year is? I forgot what it was.
Every 4 years we added an extra day of February.
Oh,
So radius, period, right? We can do the same thing we did for Titan and Saturn to figure out the mass of the Earth. You start here, V equals 2 pi r over t. Once we get our V, we plug into this equation, and then you can find the mass of the Sun. Right? Does that make sense, guys? Does that make sense? Can you try that tonight? Yeah? I would like you to try that on your own. Don't forget to convert days into seconds. Right?
That's a big number. It was like some 3 million. Sorry.
Okay?
30 million.
So don't forget to convert that. If you need to check your answer, it's on page 173.